Okay, for this problem, we have four particles. One to charge Q, one to charge 3Q, one to charge, and one to charge, two of charge negative 2Q. And they're placed in a configuration like you see in the picture below. Each at a distance A from the origin, find a simple approximate formula for the potential valid at points far from the origin. And we want to express our answer in spherical coordinates. So, of course, we know the dipole moment is the product of charge and distance of separation of charge from the origin. So, we want to write our dipole moment equation, which is just the total sum of Q phi R I. And we know that we're looking for the charge of the if particle. So we can now show the positioning of our charges in like a 2D way. So we have our z-axis and our y-axis. So we know we have 3Q here, distance A. Negative 2Q, distance A as well. Another negative 2Q, distance A. From our origin, and then positive Q, distance A. So now we gotta find the total dipole moment for the four charges. So we have P equals 3QA for that top charge minus QA plus 2QA y hat plus negative 2QA negative y hat, which equals 2QA z hat plus 2QA y hat plus 2QA y hat. And so we know in the Z direction, it's 2QA Z hat. So now we want to write the expressions for the position of the point in the spherical coordinates, because they ask for them in spherical coordinates. So we know X is simply R sine cosine Q equals R sine theta sine theta. Z equals R cosine theta. We know the scalar product of a dipole P and position vector R hat. So now we want to substitute that position in the equation in our dipole equation. So we got P R hat is equal to 2Q AZ times R hat equals 2Q A Z hat R hat simply goes 2Q A R hat cosine theta R substitute R E1. Therefore we get P dot R squared equals 2QA cosine theta. So now we want to write the equation for potential at a distance R due to the point charge Q. So we have V equals 1 over 4 pi epsilon naught R squared, R hat over R squared. Now we substitute R2Q cosine squared in our equation, and we get 1 over 4 pi epsilon naught times 2 QA cosine theta R squared. And that is our final answer. Thank you for watching this video.